Welcome everyone to Basecamp 12, session 3. Today we're going to talk about testing. David, I think I'll pass it on to you to do a little recap for session 2.
Yeah, just a brief recap. Session 2, we have a class with Charlotte, and she showed us how to create a smart contract within Cairo to create a simple counter smart contract where you can read from the storage, like read the counter, you can increment the counter, decrement, you can reset the value. She also showed us how to use components, in this case, an OpenSSL component that manages the ownership. So it's a way to protect certain methods of the smart contract, so only the admin can make changes. And at the end, she was showing us how to use a scaffold to have like a local dev environment. We have a little hiccup because we forgot how to make the change in the configuration so you can deploy it. So I make sure to record an extra video that I put on Discord, just showing you how to modify this deployment whenever you change the name of the smart contract from the default name to whatever you want. For example, the counter smart contract. So make sure that you go to Discord, watch the video. It's short one, 50 minutes. It also goes through again the installation process in case you missed that from session 1. So that was session 2. So I just pass it over to Dave to go through session 3 and testing.
Awesome. Yes. So I'm David Namdi, and I'm a technical instructor born in Nigeria and based in Nigeria. I speak English, and that's my official Twitter handle. So in this session, I'll be covering introduction to testing, and the agenda. We would like to be exploring what is testing, why test, types of testing, what is SnForge, and we're going to be taking a 10 minutes break. Afterwards, we're going to have a hands-on session where we will kind of like dive deep, getting our hands dirty, writing some tests. And afterwards, we will be taking some short quiz. So yeah, so dive deep into what we have for today. We'll be talking about testing. What is testing, which is the meat of what we're covering today? Testing is the process of verifying that software behaves as expected under varying conditions, right? So we want to make sure that the function of every contract we have written behaves as it should, right? So, but it's beyond that. You want to make sure that things work, and also to make sure that we build a logic that is kind of like trustworthy, resilient, and then ready for real world usage. So why test? One of the reasons why we want to test is to ensure that the functionality and the security of the contract we're building is kind of like guaranteed, right? So we want to validate the functionality of every logic under varying conditions, making sure that it behaves as intended. And again, we want to also prevent costly errors during development, right? So small errors often result to significant losses. And one thing we should know is that in the Web3 space, it's an adversarial environment where you should cover all cases as much as you can, right? So you don't want post-deployment errors, right? So if you can actually prevent that, cover that, capture all scenarios in your testing phase, right? Yeah. So another reason why we want to test is that we want to ensure that it kind of like enhances the trust and reliability of a given product, right? So imagine Uniswap. Users want to use Uniswap because Uniswap is a DeFi application that has been thoroughly tested. We want to kind of like instill trust in both categories, in two categories of persons, on the users who are most likely to interact with the contract, and also developers who have really tested their contract. We kind of like boost their confidence to kind of like refactor and optimize. And again, we want to also ensure that testing is an approach we use to simplify continuous improvement and iteration, right? In a rapidly evolving ecosystem where everything kind of like, Web3 is kind of like a rapidly changing environment. And one of the things we want to do is to kind of like consistently maintain the environment. So any new update, you want to like make sure that your latest changes kind of like is consistent with, so your development environment is consistent with the latest changes, right? So we're going to be having so many versions of what we're building. Testing kind of like enables you to set up a consistent environment all the time, so that whenever you're testing with the latest update, it's not really kind of like hard, right? So it kind of like enables us to adapt to and improve on existing logic, right? So also on the other hand, maintaining the integrity and the security of our contracts. Yes, this is a picture I took. If you go to rect.news, rect.news is home to a lot of hacks in the ecosystem, right? So some of them DeFi applications, NFT contracts. So billions of dollars have been stolen. You don't want to be wrecked. That is why you should thoroughly test the functionality of every contract you build. So yeah, always remember it's an adversarial environment, or you will get wrecked, and you should not be wrecked if you test, right? So it is an important phase of building contracts. So yeah, so one of the tests that we're going to be talking about different categories of tests. We're going to be categorizing them. One of those tests is unit test. So functions are isolated and tested individually, right? So you want to, in our simple counter contract, we want to kind of like test that the get count is working as intended, writing assertions. Basically, all of our tests is about making sure that every state change is valid, right? So before the state change and after the state change, right? What was the case and what is the post state change, right? So make sure that your assertions are very valid, right? So unit tests in the case of our counter contract enables us to isolate each of the constituent functions of that contract, right? So in our case, get count is 0. We want to make sure that is 0 after deployment. And also want to increase count by 1. We want to like, oh, after the state change of increase count, there's an assertion logic to make sure that that state change was valid, right? So we can actually categorize this kind of test under unit test. And it kind of like constitutes the highest number of tests in a code base, very fast to run. So yeah, like I mentioned, an example here is testing the increase count function of our counter contract. So the other category of test is integration tests, right? We want to validate the logic of multi-contract interactions, right? Using, we're going to learn about in dispatchers in the course of this test session. We're going to be seeing how we can actually leverage the dispatch of a given contract to interact with the functions of that contract. That does not limit it to that particular contract. You can actually use the dispatch of a given contract A to interact with contract B, and that is what brings about composability. So in a case where we have a staking contract, we want to make sure that before a user stakes, he has, first of all, initiated an approval of the token, then before kind of like you allow the deposit of the given token in the staking contract. So kind of like analyzed there in this example, right? So it is one of the cases where we want to kind of like see the interaction between contract A and contract B. It is all categorized under integration tests. So generally, there are fewer tests than the unit tests, and then kind of like slower to run because you're trying to like go around multiple contract interactions. Yeah. So we have end-to-end tests, but for the purpose of this session and for the hands-on session, we'll be covering only the unit test and the integration test. And again, we have another category of tests. We have end-to-end tests. So we have a scenario where we're using the UI to see how it interacts with the contract logic, right? So kind of like we have a UI and we are also leveraging the contract logic. So basically that. So yeah, in all of this, we'll be covering how SnForge is a tool to be used to test our contracts. And that is the core focus of this session, right? We're going to be talking about what SnForge is. So SnForge is a tool built by StackNet Foundry. It's kind of like a testing framework for testing smart contracts, right? So if you're coming from Solidity, you must have come across Hard Hat and also Foundry, right? So in StackNet, we have a tool chain called what? StackNet Foundry. So StackNet Foundry, one of the components of StackNet Foundry is SnForge. So while SNCast enables you to interact with the network, you can actually, from your CLI, perform some commands. You can actually create an account, deploy an account. We have another component responsible for testing, right? You can actually use SnForge to initialize a new project and also use it for testing. So for the purpose of this session today, we're going to covering the purpose of SnForge in testing. So yeah, so basically what SnForge is all about.
Dave,
so yeah,
I have a question from Dimitris. Sure. Is it possible to do fuzz testing as well?
Yes, fuzz testing is important, right? So I think I covered that towards the ending of this slide. So fuzz testing, kind of like you want to see how a contract behaves under varying degrees, right? You pass in an argument into the test case and kind of like give it kind of like from your command line, kind of like how it should kind of like run. So basically, so many scenarios. So how it behaves, probably you're passing a U32, you kind of like want to from the low value and to the max value. So kind of like how it behaves under varying degrees. So yeah, so force testing is another category of testing. And on the other hand, fork testing. So both of them are kind of like the advanced testing categories, right? So if we have time, we can actually cover some of them. But for the purpose of this session, we will be only treating unit testing and integration testing. Yeah. So to answer that, force testing is a valid test category, as well as fork testing. So in the other kind of fork testing, you want to kind of like take a snapshot of the existing chain. So let's say Sepolia, you're not making change directly to Sepolia network. You're kind of like creating a version of the Sepolia network, and you're performing state changes to this forked version, right? So basically, how this works. So basically, at the end of the day, these are the two advanced test categories. So yeah, I don't know if you have questions.
Nothing for now. You can continue. I'll let you know if there's a question coming up.
Awesome. So yeah, so we'll be writing some code, and I'm excited to walk us through this. So yeah, in the last section, Charlotte did an amazing work setting up a simple counter contract. So
sorry,
yeah,
David, can you increase the font size before you start?
Awesome. Can you see now? How about now?
Yeah, I think that's perfect.
Awesome, awesome. So we have a simple counter contract where we have an interface with get counter, increase counter, decrease counter, and reset counter. All of these methods are housed inside the as an interface in this file, right? Where we have the counter, which is what houses our state, our storage, and then the implementations of this iCounter trait. So basically, to wrap up what she covered, iCounter is kind of like the blueprint. This is the blueprint, whereas in the counter, we have our storage, and we have the implementation block. So this kind of like implements all of the traits, the blueprints, methods that we have in our iCounter. So we're going to be testing them and see how they behave, making sure that each of the state changing functions behave the way we want them to behave. So basically that. So let's write some code. So I believe all of us have this environment set up. So if you do, so I think you will want to, under your, inside your packages, open it up to the Foundry, and we have our contracts. Within our contracts, we will have the tests folder, and this is where I'm testing, right? So yeah, so to start, basically these two files exist separately. So we are going to be importing the necessary libraries and binaries, right? So first of all, we want to tell the test file about some of the necessary files we want to import, right? So yeah, so let's start. So the first one, we're going to be using SN. So we're inside our scap.toml, we have, this is what is responsible for testing, right? We have this SnForge standard library. So we're going to be using that. So David, please let me know if you have any questions.
The question is, what template are you using for VS Code?
Oh wow, they like it. Oh, I think I think I've forgotten, but I think
you can go back to Discord.
I'll talk about it like.
Well, in Discord, you can put it later.
Probably. Oh, sure, no problem. So yeah, but now let's focus on the code. Yeah, so I think I'll talk about it. I think. Oh yeah. So yeah. So the first thing we want to do is import this library here. So this has a lot of methods, right, that we want to be using. for our environment, right? Set up our test environment. So this is the most important dependency we'll be using for our tests. So the first thing we want to do is to declare. Remember, before you deploy a contract on StackNet, you must first of all declare it. Then the declaration of that contract will give you the class hash. That class hash is usually used to deploy the contract. So we're going to be performing that using this declare. I think we're going to gradually take it one at a time so that we understand step by step what is happening. So we're going to have, I'm going to create a simple util function, a simple deploy util function. And for me, you can call it anything you want. So you can call it, I usually would like to do this, but you can call it anything, right? So basically this, so what this deploy function is going to be doing is to, anytime we want to deploy our contract, we're going to be using this deploy function to kind of like a util function that we'll call first before our test case, right? So we want to, first of all, declare our contract, and to do that, we'll be using this declare method imported from, given to us by the SnForge standard library. So so it's going to give us the contract class. Like I mentioned, you declare, it gives you a class hash. So we're going to call it contract class. So we're going to call declare. Declare is taking, so you can actually hover over a given method to see what it's taking, right? So it's taking a byte array. So you can actually know that this is kind of like how to, byte array kind of like longer strings, right? So the name of our counter contract, which is in this case, so the name is here. So we call it what? Counter. So let's copy that and come here and call it counter. So what is the next thing we're going to do? This gives us a method called what? Unwrap. So we're going to unwrap. Then we can call contract class. So basically this. So this was auto imported for me. I wanted to kind of like use them one at a time. So this declare result is kind of like what we use basically to handle the import, like, right? So whenever, anytime you kind of like declare, this is kind of like a util function to kind of like give you access to the contract class method, right? So basically this. So with this, we have successfully declared. And some of us may have questions about unwrap. Unwrap is how we kind of like handle errors, right? We can actually do this or this. Let me do this. I think we can actually, unwrap is ways we can actually handle errors in Cairo. So we have another one called what? Expect. You can actually do this. So expect is expecting kind of like a fault. So I usually like this better than unwrap because unwrap can actually break and you don't know what is really breaking in your code. But when you say expect means it's kind of like giving you a way to kind of like log the reason for the failure, right? You can actually say failed contract, failed counter declare, failed to declare. So we can actually do this. So so this should also work. So in most code bases, you'll see either this or this. So so any one of them you want to use, in this case, unwrap or expect, know that they behave the same way. So so any one of them. To handle errors and when it throws, you know what happens. I would usually prefer that you use expect. So so I can, let me take this out, but for this session, we can use unwrap. So basically that. So the next thing we're going to do is to kind of like serialize our constructor arguments. So what is serialization? Serialization means we want to pass our state, our constructor arguments to this, when we're deploying, we want to like pass them into felt, right? So we will look at our counter contract and do we have a constructor? Yes, we do. And we'll see one of the reasons why why testing is important, that this logic will modify it in the course of this session. As a matter of fact, I think I should do that now because every time we deploy this contract, the count is 0 and something is happening here. This caller address is not the address of the deployer. In Solidity, you can actually do it and it's kind of like msg.sender. But in Cairo, when you're saying get caller address within a constructor, the UDC the universal, so I think, let me take a look at that. So let me tell you about the UDC. Yeah. So UDC, yeah. If you can see my screen, please let me know. So yeah. So there's a warning every time you're going to use get caller address. Like in our case here, where we have get caller address here, right? We're passing it as constructor within our constructor when we're calling the ownable.initializer. So basically, all the time is going to be the address of the UDC, Universal Deployer Contract. Kind of like you are not in charge. That means you have lost ownership of this contract automatically. So the best practice is for you to pass your deployer address as an argument, right, in your constructor. So we want to have something like this. We can actually say owner, which is going to be of type owner address. Let's say of type contract address. Yeah, so we want to do this, and we want to pass this as owner. I think, let me do this so that some of us who really don't understand can understand. So yeah, so this is flawed. So you want to do this so that you don't lose ownership of this contract. So yeah, so you pass it as an argument, because this universal deployer contract is what is kind of like the caller. When you call get caller address, it is going to give you the address of this UDC. So you want to do this as a safe way to initialize ownership of this contract. Yeah. So yeah, so that's that. And again, I think basically when you do write 0, basically at every time for every state variable, in our case counter as a state variable, the default value is is 0, right? Is set to be 0. So I think we may want to kind of like pass in an argument here. So we can actually say init value. So this kind of like so gives us U32. So this gives us ability to kind of like modify this as much as we want, right? So yeah, so this is kind of like a valid way to get started. Yeah, I don't know if there are questions. So yeah, David, are there questions?
No, not for now, David.
Okay, no problem. So yeah, I can go. So yeah. All right. So yeah, we want to also have in our counter contract, we have a constructor, and we want to kind of like have an, let's say, kind of like a util constant, right? So let's call it 0 count, and we want to say that this 0 count is of type U32, and let's call it 0, right? So every time you call a const, you kind of like will pass in, annotate it with the type, right? So we're trying to like pass in 0 as the default value. Right, we're going to use this throughout the course of our contract. So yeah, so we want to serialize some of these. We want to serialize the arguments that we're going to be using as in our constructor. So one of them, in this case, is the fact that we need an owner, right, and an init value. So these are constructor arguments. So yeah, so what I'm going to do is to let me define my owner. So it's going to return contract address. And you can see now it's saying type not found. So what are we going to do? We're going to kind of like call stacknet, and then stacknet gives us our contract address type. So yeah. And this is still yelling at us. It's kind of like I'm saying, what do we mean by we don't have a return value? So we're going to have owner trying to, yeah, so, and we're going to unwrap. So let's say unwrap or expect any one of them. You can use any one of them works. So this or this, any one of them. So anytime you want to use it. So you can say this or call unwrap. So basically any one of them should work. So yeah, so you can say fail to convert to owner like that. So any one of them, you can actually use that. So yeah, so I prefer expect anyways. So yeah, so what are we going to do? We're going to like serialize our constructor. So we're going to say const call data, let's call it, it's going to be a mutable type. So let's say call data, and it's going to be in Cairo. Every time we want to pass in values into our constructor is of type it's an array of felts, right? So we're going to say an array of felts 252, and yeah, it's an empty array, right? So we're going to so let's call it yeah. So this is it. So we want to want to serialize. So in our counter, the first value is our init value. So what are we going to do? We're going to say our init value. You can actually say init value. Let's call it 0. So let it be 0 count, right? So let's call 0 count dot what serialize. So serialize, we want to reference our call data, right? So yeah, so this will convert this 0 count to felt that can actually be passed into kind of like transmits it as a constructor argument, basically. And also we need to kind of like pass in this, because the first argument is our init value, which we're saying it should be 0. Whether or not we want to, by default, this is automatically before you initialize it by calling a state changing function, it is 0 by default, right? Just so we know. But for the purpose of this test, I will be saying my init value is my init 0 count is 0. So yeah. So the next thing I'm going to do is I'm going to serialize my owner. I'm going to say serialize. I'm going to have a reference to my call data. And yeah, so call this, I think we're good. So yeah, so the next thing is we have declared our contract. Now we have serialized our constructor arguments. The next thing we're going to do is to deploy our contract. So what do we do here? Like it a bit clean. So what we're going to do is to this contract class, right? This is what we're going to use to deploy our contract. So yeah, so the next thing we're going to do here is to say our contract class dot deploy. So yeah, I think the compiler is kind of like yelling at me because I have not called this. There's a method on that I'm meant to call. So it's going to be contract class street that gives me access to the deploy. So most of the times when you're confused about what a function is, you can actually hover over it. The VS Code has a way to kind of like tell us what we're expecting, right? So basically what we're going to be doing here, we're going to be passing kind of like a snapshot of our call data. So we're going to say call data. And then we want to what? You can say unwrap either this or I like my expect. So yeah, I want to say fail to deploy. So, but this is also going to return a value, right? So when you hover over this, you can see that it's returning a syscall result, which is kind of like a tuple of a contract address and a span, right? But for us, we're interested in the contract in the first return, which is this. So basically, we're going to have the contract address of this contract. So we're going to say so we're going to do this. We're going to say contract address, and the next one we may not need this for now. So the next thing is we want to kind of like initialize our deployed contract. So how do we do that? I don't know if there are questions. Please feel free to let me know those questions. I will want to go through them. So yeah, we want to, on the other hand, we want to, this iCounter has certain traits that we want to use to kind of like initialize our deployed instance of our contract. So in our code, what we're going to do is to kind of like fetch that. So to do that, we will we'll say use. So what are we using here in our scarp.toml file? We're going to go here. This is the name of our package. So we're going to copy that, and we're going to say this. So what we're interested is in the counter, and basically this. So we want the iCounter dispatcher, and we want the iCounter dispatcher treat. Yeah.
Dave, question from Leon.
Yeah, sure.
Why did we have to serialize the constructor?
Come again?
Why did we have to serialize the constructor?
Okay,
The zero
so
count, the owner.
why do we have to do that? So we need to convert it to fields, like kind of like at the end of the day, remember we said the call data is of type array. So this is an array of felt 252. We want each of these values we're passing into this array to be converted to felt at the end of the day. So that is basically what we are saying when we call the zero count, which is in this case the first argument in our constructor. So this is the need value, and the second argument, that's the owner here, which we have actually created using, so let me say, our test account. So yeah, so this guy is the owner. We want to kind of like simulate an owner in our test case. So we have to serialize that basically. So this is an array of fields. So you have to convert each of these to kind of like a passing to be passed into this array. So basically,
there's two more questions
so
about why does it need to be felt 252?
So you know, basically at the end of the day, felt is the default data type in Cairo. So under the hood, all of what we're passing, no matter the data type, is kind of like eventually converted to a felt. So if you want to pass in any argument, in this case, in our constructor, you must first of all pass it as a felt in your call data. So we have done that here. So we're passing in a reference of our call data to our deploy method. So basically, if you check here, you can see that we are looking at our constructor call data, which is an array of felt. So basically that. So that is how we do that in testing. So remember, we're not testing yet. We're trying to like create a util deploy function because we're going to have different scenarios, right? We're going to have each scenario to test each of these methods, right? The get counter, the increase counter, the decrease counter, the reset counter. So we're going to, at every time we're going to test each of those functions, we need to kind of like call this deploy function, which returns some things, which is what I'm going to cover next. So yeah, so we have this. So we're going to say let's initialize. Let's have it kind of like let's select our counter should be kind of like an instance of our counter should be this counter dispatcher. We pass in I counter dispatcher, then we pass in the contract address, then the contract address. So basically this. So this is how we do that in Cairo. So this gives us an instance of our counter, our deployed counter contract that we can actually call certain methods. Like all of these methods will be available to us because we have kind of like initialized this dispatcher with this contract address, in this case, the deployed result of our contract class. So yeah, so with this, we can call .get count, .reset count, .increase count in our test. So we'll see how to do that shortly. So yeah, so we have our counter, and we also want to have other things too, because we're going to be seeing how to handle our okay, I think for now, I think we're good to go for now. Let's see. We want to return this counter in this util deploy function. So we're going to say we just need the contract address. So in this case, we're going to say our counter. So this is it. So by default, this is kind of like implicitly returning this counter here. So no. So sorry. So we're going to have our counter dispatcher basically, yeah. So yeah, so we're good. So we have the deploy and we're good to go. So the next thing we're going to be doing is to be checking, is to test. So for our counter contract, anytime you initialize it by calling the constructor when you deploy, all of the default state variables, you want to make sure that they kind of like are valid enough. So yeah, so what we're going to do in our case, the state variable here, the counter, should be 0 because should be any value we pass into here in our argument, right? And in our case, we're saying it should be 0, right? yeah, I think we should kind of like make it kind of like modular to make it kind of like easier for us. So we can actually say, let's say, init, let's call it like this. I think this should be fine, so that it's kind of like easier for us when we want to call, instead of zero count, we can actually say init value. So yeah, so every time we deploy, we pass in a value. So yeah, a question?
Yeah, can you show where you bring into scope the iCounter dispatcher, the import?
Oh wow, yeah. So this, let me talk about that. So basically, for our iCounter dispatcher, this is as a result of the fact that we have this trait here. So this trait, every time we define a trait with this annotation, right, with this attribute, the compiler automatically creates a dispatcher and a dispatcher trait, right? So dispatcher is what enables us to kind of like initialize our contract, right? So in our case here, in line 26, this iCounter dispatcher, we don't have to create it by ourselves. As far as this is defined as an interface, the compiler automatically creates just the name of the interface, then a dispatcher to it. So yeah, so you can see that the iCounter, then a dispatcher. So yeah, and also the dispatcher trait. This dispatcher trait enables us to call the methods in this iCounter. So basically that. So yeah. So the next thing we're going to do, we're going to test that. We're going to test. So we're going to say test counter deployment. So what we want to do is to call this deploy function, right? So this util deploy function is going to be helpful, right? So remember, in our case, at this point, we're just returning the dispatcher. This is kind of like an instance of our contract that we can actually call in our tests to call the functions to test them. So we're going to say let counter will be, so yeah. So this automatically gives us access to this deploy util function, and it's yelling at us because we need to pass in an argument, right? In our case, we want to say, let it be what? Let it be 0, right? So we want to, let's create, let's count 1. Let's call it, let's create count 1. We want to assert that, let's see, let count 1 equals to counter dot, yeah. So automatically, what is giving us access to all of these methods in our, you can see we have automatically access to get counter, all of the methods that the contract kind of like gives us, right, is because of the fact that we have this dispatcher trait, right? So yeah. So we will say dots, we want to get counter in our case. I want to, this is the meat of testing. Testing is now, it's not valid without an assert keyword. So assert keyword is what we're going to use to validate all of the variables and the state change that we make from time to time in our tests, right? So in our case here, the default value upon deployment of this contract is 0, is anything we pass in here. And the ownable is the, this initializer will initialize to any argument we pass in our constructor, right? So that's what we want to test. We want to assert, what do we want to assert? We want to assert that count 1, let's say count 1 equals, let's say, let's call it in 0. Remember, we have this as 0 count already. So let's say 0 count. Remember 0 count, we created the util function here, 0 count, right? Then we want to say count not set. Two state variables, in our case, the ownable and the counter. We want to make sure that they are valid, right? And we want to assert that, what do we want to assert? We want to assert that who is the owner of this contract. That is what is going to bring us to utilize another valid library given to us by OpenZeppelin. We're going to use OpenZeppelin's access to, we're going to call, I think we're going to call the interface. Okay, we're going to call the ownable first. Then it gives us access to the interface. So we have the IOwnable and the IOwnable dispatcher treat. So we have IOwnable dispatcher and IOwnable dispatcher treats. So yeah, this is what we're going to be using here. So, but how can we add this? Remember, in our contract, we are just kind of like in our deploy util function, we're just returning an iCounter dispatcher, right? Which is just the deployed instance of our iCounter contract. But we want to kind of like have access to more than just the iCounter dispatcher. So in this case, we're going to use a tuple, right? So a tuple gives us access to more than one type to return. When we're returning this, that means we're returning multi-types. So yeah, we want to have access to this IOwnable dispatcher. We want to have access to this. So how do we have access to this? So we're going to say let ownable equals to IOwnable dispatcher. And remember, how do we have an instance of the how do we have an instance of, I don't know if there are questions. We need an instance of we need an instance of the IOwnable, right? So we will say contract address. So yeah, contract address. So yeah, so we should have this. We have ownable. So yeah, so we have access to the methods of ownable. We're going to see how we're going to use that to perform our assertions here. So yeah, so in this case, I think this is going to yell at us again because we have more than one value returned here. So we're going to do this.
Just to mention, David, that just so people know, when, for example, in line 27, when the property has the same name as the value, you can just use the name once.
Come again?
Like on line 27, you can remove one of the contract address and it will work still.
Yes. Yeah, thanks. Oh yeah. So this is kind of like a shorthand method. So you can actually do this. So yeah, so kind of like to improve readability. Yeah, so this is good. This is valid. So, but to be explicit, this works, but this is kind of like readable. So yeah, since they are the same. So yeah, so we need an instance of the ownable because we have we are extracting it from our deploy. We're going to say what we need access to owner, right? And one of the things we're going to do again in our case is to kind of like we want to ensure that this counter contract kind of like deployed in the correct way. So right, so we need access to the owner. So we want to make sure that this is this, otherwise owner not set. So yeah. So with this, we have kind of like imported the necessary binaries. We have kind of like set up our deploy util function, and we have our first test case, which is test counter deployment. So we want to copy this. So something is happening here. So for me, basically, you can actually come to the root, which is in our case, anywhere you are within. We can actually come within as far as the root of this folder structure is concerned. You can actually do yarn test, then the name of the test. But if you want to be more precise, you can actually narrow down into the packages, go into Foundry, go into contracts, and then want to go into test, this test contract. And inside here, you can actually call the method SnForge test. Either of this works, so right, I can actually split my screen to see the other instance where we can actually do yarn test, then the name of the test. So we'll do SnForge test. So yeah, I think it's yelling at me. There's a warning here. So let me see. So I think it's still warning to you. I think all I want to do 7 dot, I think 7.0. Let me do this. Let's go again. So SnForge test, we want to look at this test file and we want to validate that this test is valid. So to recap, to use any of these tests, you must annotate the function with this keyword test. So without this keyword test, this test will fail. So yeah, so this is kind of like an attribute you must use to kind of like tell the compiler, in this case, the SnForge, that you want to test this this function, right? So yeah, so that's one of the things that is worthy of note. So allow it to compile. I don't know if there are
Question,
questions.
Dave. In the meantime,
Yeah,
could
sure.
you open another terminal and do an SnForge version? I just want to see which version do you have installed, which binary.
All right, nice. So, yeah.
Okay, just to mention, because last night I pushed like a new version of this same 2.9.4 image that has SnForge 0.38.1, which is the one that
Wow.
comes with a scaffold predefined. That's fine. I think it's both compatible, but if it's not, that's why I put on Discord, how do you actually get the new version? I know it's not a good practice to
Yeah.
replace the same image because it's the same version, but that is the version supported by scaffold, so I kind of just keep pushing. I want to keep it synchronized, both of them.
Okay, no problem. I think after the end of this thing, we can actually see if we can actually synchronize to the version you have currently.
Yeah, but it should work. I think they're both compatible still.
Yeah, sure. So it's going to compile. I'll wait for that. We want to get current count. So yeah, so it's passing. So basically, I'll go over this. So this is our assertions, right? So remember, in our contract, we have a component, right, responsible for ownership, right? So basically, what we want to do in our contract is to use Open Zeppelin's component, right? So this ownable component gives us access to this to the ownable component storage. In our own case, we have it as ownable, right, which is a sub storage, right? So while importing, we want to do this. We want to have access to, first of all, it has an interface, right, which is the iownable dispatcher. And to call the methods within this ownable, you must import this iownable dispatcher trait, right? So that gives us access to methods like owner and all of the methods that ownable gives us access to. So yeah, so this is how to import it, right? So yeah, the ownable interface reference, the dispatcher, in this case, the iownable dispatcher. And also make sure you import this, because without this, you will not have access to that method. So you can see this should throw an error, right? So yeah, so always make sure you import the corresponding dispatcher traits, right? So for every dispatcher, there's a corresponding dispatcher trait. Yeah, so I think our test passed. We can see that when we run SnForge tests, and then we just have one test here. In this case, we want to test the state variables that of our contract, that it's kind of like it's in their default state. In our case, it is count 0, and then for the ownable, it is the owner, right? Right, yeah, so basically that's how to go about it. So we're going to test, what we're going to do, we're going to test the next thing, which is in this case, this state change that happened here. In our contract, we have an increased count, right? So look at this increased count. What is happening here? We want to check that every time this function is called, we read the current count and increase it by 1. So basically that. So yes, so that is what we are trying to do. We're going to make sure that it is valid here. So we can see test. So for easy, you can actually say test. Let's call it this. So yeah, so yeah. Can you see my screen?
Yes.
Yep, all good.
Okay, no problem. Sorry, I actually wanted to make sure this. Yep. So yeah. So the same thing we did here. So every time, so you're going to see the importance of this deploy. So we're going to always have this, just instead of writing it all by ourselves, we'll have a reference to our deploy, and then we'll have the methods in our case, the deployed counter contract and the ownable contract, right? So yeah, so we're going to test that it increases. So the next thing, okay, I think to do that, we also want to make sure that okay, let's say let count one. So basically what I did here, so no need. So let's assert this. Okay, let me just copy this so it's easier for us, so we can actually cover other test cases, right? So basically what we're doing here is to get count, and we're asserting that this count is zero count, right? Because we're passing in zero count when we're deploying. So yeah, so that is it. And the next thing is to call counter dot increase counter. So this is the transaction we want to do. So this is the state changing transaction, which is increase counter. So when we increase counter, what do we want to do? We want to retrieve current count. So yeah, I can actually say let count 2 equals to what? Counter dot get counter. So basically this. So yeah, and the most important thing that makes our function work is the assertion, right? So we want to assert that our count 2 will be equals what? Count 1 plus 1. Yeah, and let's say invalid count. So yeah, so basically that. So what we are doing, so because we're not using this, I think let me just underscore this. So basically what's happening here is the fact that we have asserted that our count, when we deploy this contract, is kind of like 0 because this is where we have it, right? And then after that, the next thing is to kind of like get the count, which is in this case, we want to make sure that the count is 0. Then after that, we'll perform a state changing transaction, in this case, calling our increase counter. So that will get the current count and add +1. So we want to make sure that that happens successfully. That is why we have count 2. We get the count. I'll save it in this variable count 2, and we want to make sure that the current count, which is in this case 0 plus 1, is I think we should have 2 at the end of the day. So right, so yeah, so we want to test. So we want to make sure that the test is passing. So SnForge test will run and run all the files. So it's going to run test counter deployment and also run test increase counter. But I think the next time we're going to test in isolation. We're going to test individually. The next one we're going to test. Instead of doing test increase counter, we're going to use a keyword, right? To kind of like isolate each of these tests. And also we're going to learn how to kind of like ignore other tests that we do not want to run from time to time. So yeah, while it compiles, we'll wait for it. And if there are questions, I would like to take those questions. So I like
could you show a test failing?
Yeah, sure. I will do that. I will do that. Yeah, so let's scarf format. So yeah. So yeah, we're going to test the next thing that I think within this increase count that we're going to have an assertion logic also to make sure that to test if it fails. So we're going to test that. So let it pass. So this passed. So the next one we're going to do is to capture the failed scenarios, right? I think.
No, I mean just make a modification so it fails, so people know.
Oh yeah, sure. So like let's just call 5. So yeah, let's do this. So I think this should say invalid count. Yeah. So make sure that this error message you're throwing out kind of like should show. I think it's kind of like unique, each of the assertions, so that when it fails, you know that what is failing. So I can have to like I think copy this. That count increased by 1. So yeah. I think for those of us asking, I think this is cypherpunk. And I think, yeah, extension, I think sidebar, yeah, cypherpunk. Yeah, so this is it. I think, yeah, so cyberpunk rebuild. Yeah. So for those of us asking, so this is it. So yeah, so you want to do that, you want to install that later. So yeah, so you can see that our test is failing, invalid count as triggered by this line 62. That means if it is not increasing by 1, it should throw this panic by this error, right? And we are seeing that it's working very well. We can see that this is the felt value of invalid count, and it's indicating that if it is not 1, it should fail. So yeah, so we want to revert to, okay, yeah. So if that count increased by 1, sorry, I think 1. So yeah, so we should have this plus 1. So yeah, so this is how we test that. So we'll go to next test. We want to do something, right? So we want to test that. We want to test for emitted events, right? So I think in line 70, we can see that we are emitting the increased count. I don't know why this. So yeah, we want to test something here. We want to make sure that our increased counter, whenever we call it, kind of like emits this increased event. So yeah, so basically we can test that. We can say test emitted increased event. So yeah, so specifically for that, so what I'm going to do is to get this line. So yeah, so when we have this, we want to kind of like, let's say, let's increase counter, let's say counter, the increase counter. So we're performing a state change, and what should happen? We want to make sure that we capture this in this test, all the emitted events. So in our case, we have the account that is calling, right? In our case, we want to kind of like emit this address, right? So how do we do that in tests? So yeah, how do we do that in testing? So before we do this, there's a method that is given to us by the SnForge standard library. We want to call the method spy events. So this gives us access to monitor all the emitted events within our contract. And where should we call it? We should have it here, spy events. Yeah. Or you want to make sure that this spy event is called before you perform any state change. Otherwise, if you bring this afterwards, you will not capture any emitted event. So yeah, so you want to make sure that every spy event in this case is emitted before the state change. It's kind of like you add this line before any state change. And I'll also want to introduce us to another method given to us by the standard library, which is in this case, want to mock who is calling, right? Mock caller address, right? So we want to see this cannot be found. We want to import it here. So it's a cheat code. So if you want to mimic the caller of a given function, we want to say cheat address. So yeah, basically that. So we're going to use this. So the essence of this is to make sure that we want to simulate somebody that is calling this increase count function. So we want to mock a caller, right? We want to mock a caller, right? So what is it taking? So always kind of hover over any given, if you don't know the arguments to pass into it, that kind of like gives you an insight into what to pass in. So you can see that in here, we're getting a contract address and the caller address. So in our own case, we're calling what? Counter dot. So counter gives us a method called contract address. So this is how we target the address of the counter contract. I want to see that. So we will need to add more. So let's just be fast. So we should do this. So this should be another entity calling. So let's call it user one. So yeah, so this is also user one. So yeah. So these accounts represent different entities, right? So this is an account that we want to simulate as an owner and want to have another account as user one. You can call it anything, but this is a convention how we do it in testing. So right, so we have an account that's an owner, we have another one representing another entity, user one. So basically, we want to use user one to call this increase count. So before you perform the state changing function, in this case, increase counter, we want to call this method. So SnForge will simulate the call to this contract address, to this counter contract as user one. So basically that. And so I think we want to also stop this sheet caller address. So we don't have it here, so we're going to import it. Always make sure I'm not just importing all the methods. I want to import them as necessary, right? So yeah, so we're going to, so that we don't have an over-bloated test. Sheet caller address. So basically this. So we have access to this. So we want to stop the call to our counter contract. So yeah, we're good. So the next thing is to make sure that we want to, we want to emit the events. So how do we do that? Remember, we have this spy events, and we're going to use it here to spy. So we have a method called what? Assert emitted. This assert emitted will work because we need so when we hover over this, we can see that we have an array, right? So it's expecting an event, which is an array of tuples, right? This T is a generic, so anything, it's kind of like a placeholder, right? So we want to have an array, a snapshot of an array, right? And this array is going to have a tuple. So the first value of this is kind of like, it's going to be the contract address. Remember we kind of like want to pass in an array of an address, right? And a generic type. So this first argument in this array is going to be our counter dot contract address. Then this brings us to the next thing we need to import in this our test. So the next thing we're going to import here is we want to go in here and we want to import, let's say we can actually do this contract, then counter, then we want to import the counter, right? So yeah, so we can actually do this, or we can actually pass it in here. So it's kind of like easier for us, but any one of them works. So just so we know that. So we want to kind of like pass in our counter, then we have our events. Then the next thing we're going to have is the method we're calling, in this case, increased. And basically what we want to do also is to kind of like have this and kind of like reference the increased emitted event. So what is it we want to capture here? We want to capture the account. Account is going to be of type who is calling. So in this case, our user one. We can see that this is yelling at us because it's not visible, right? So we want to go to the counter contract and we want to make sure that the event here is kind of like pub. In this increased, we want to also make sure that this is also public, right? So this struct is basically what we want to target in our test. And so basically this, so I think I should do scarp FMT to make sure my code is formatted. So now time to test. So what do I do to isolate all of the other tests? So I want to use another keyword called what? Ignore. And I will kind of like do it here again. So with this, when I run SnForge tests, it will ignore every test case annotated with the ignore keyword. Yeah, the ignore attribute, sorry. So yeah, so we'll wait for this. And also,
Hey, Dave, there's a comment
sure.
in the chat that can you reduce the size of the screen a little bit?
Oh, wow. Okay, is this fine?
Yeah, I think it's better.
Oh, sure.
Thank you.
Nice.
Also a question, what is a scarf FMT?
Oh yeah, FMT means format. So so let's see, let's scatter this a bit and then come here and do this. Let's scatter the code. And then in another split, I want to do FMT. It's kind of like you see, it's all formatted cleanly, like yeah. So makes the code clean and easy to read. It's a built-in method, right? So just call this automatically. This should format your code in the event you have it scattered. So yeah, so this is one. How do we also know that this is actually working well? We want to kind of like introduce us to another method called what? Spy, assert, not emitted, right? So the same thing we're doing here, we want to ensure that it is only this increased event that was emitted in this contract, right? So yeah, we're going to have a reference of an array. We'll pass in our array here. So remember, always hover if you're in doubt, so you know what arguments to pass into a given method, right? So in our case, we need, so basically what we did here, right? So so just to be fast, not to waste time, come in here. So instead of, we can change this to what? Decreased, right? Yeah, and change it to decreased. So yeah, to make sure that, oh, yep, I think there was a mistake somewhere. Yeah, I think this is fine. So I can actually do scab FMT. Oh yeah, I have an error. What's the error? Okay, I think let me just to make it just fast, so I don't want to waste time. So just come here, as I have not emitted, just copy this, just change the arguments in this case, decreased, and here we call decreased. So yeah, so we want to make sure that it is the event that we want emitted that got emitted. So yeah, so we'll run this. I think still not clear. I think scab MP. So yeah, so just format it. So yeah. Want to make sure that every time the increase function is called, it emitted the appropriate event, in this case, increased. So yeah, so that's why I'm saying assert not emitted. So yeah, let's see the outcome of our test. Remember, other tests are not called because of this new keyword, right? So you use ignore attributes on the test to kind of like ignore the given test. So basically that. So yeah. So remember, every test must be validated, right? Every test. So in this case, so every function of a test of a contract must be validated. In our case, we've tested the increase counter. We're going to come here and make sure that all these assertions here, that we write a test case to make sure that we capture that the value cannot be increased, kind of like cannot be decreased below 0. So yeah, so that's what line 75 is doing. So we're going to write a test to make sure that each of these functions is kind of like validated to make sure it's working well. So that's the essence of the test. So the next one we're going to do, so our test passed, we can see that it only is emitting increase and not decreased, right? So yeah, so that's the next. So the next thing is we want to kind of like want to learn how to kind of like capture failed scenarios, right? In this case, in this discrete counter, something is happening here. We're saying that every time a value is 0, it should throw an error that the empty, this is an error it should throw. I think we have that error in our, I think there's a module called, what is that? I think empty counter. Where is it? Okay, yeah, so we have this error. So we want to capture this scenario, right, in our tests, making sure that every time a value is 0, the state variable, in this case, our counter is 0, we don't want to kind of like decrease because we want it to behave well so that it does not underflow. So yeah. So yeah, so we're going to call the safe dispatcher method. I'm going to say fn test safe panic decrease counter. So yeah, so basically what we did earlier. So I'm going to ignore this with so yeah, I'm going to call this, bring this guy here. So yeah. So in our case, we are going to learn about something new here. So we know in our deploy util function, we're only returning the I counter dispatcher and the enable. How about another method? We can actually add something here, call it I counter safe dispatcher. So this method is not found. We have to import it here. So we have to say I counter safe dispatcher. And to call the methods, we will call, I think when we get there, we'll know how to import it. So I think, oh yeah, so it's yelling at us because we have changed the configuration of our deploy. So yeah, we should have let safe dispatcher. I can call it anything, but you can call it safe dispatcher, safe counter, anything. So yeah, so we can call I counter, yeah, something like this. Then our contract address. So basically this. So come here, and we say we want to return our safe dispatcher. So basically, this is going to give us some methods, right? So we're going to get access to certain methods we're going to be using. So you can see the compiler is yelling at us, so we have to kind of like modify other case test cases. So yeah. So yeah, in our case, we want to use this safe dispatcher. So how do we use it? At this point, we know that we want to have an assertion, right? We want to assert that counter dot get counter equals to what? Our 0. Remember our 0 count, yeah? So invalid count, like, yeah, so yeah. So it is 0. So an attempt to reduce it below 0 should throw an error. So how do we do that? We're going to introduce a method called what? Match. So we're going to perform a call to this decrease counter. So basically what we're going to do is to say come here, say save dispatcher dot decrease counter, and we need a lot of we need 2 things to happen, right? So this is going to return, we're going to check for the variance, right? In our own case, we want to see that if it's okay, we want to make sure that it captures, you want to make sure that it panics, right? So we have a panic, let's say cannot decrease 0. And we have the other variant, which is result. This kind of gives us custom way to kind of like handle our errors. So yeah, remember the aim of this test is to, so you can see it's yelling at us here. So we need to import the I this safe dispatcher treat. So every time you have a dispatcher, always import the corresponding dispatcher treat. So that is why we're having that error there. So it's okay. Yeah, I think we should delete this. Yeah, sure. No. This is safe dispatcher. Counter safe dispatcher treats. Yeah, sure. So yeah. So when we have this, we should have an assert. What are we asserting? We're asserting that this error here, we want to kind of like desnap it, and then have access to kind of like what is the error message? So decreasing, I think, yeah. Otherwise, we want to, this returns an array, right? So we want the first index of that array. So we want to use, so these are two ways to kind of like assess that first index of this, of the return value of what we get in our error. We can actually call it anything. We can see in some documentations, you call it panic data. But in my own case, I want to call it E. You can call it anything, kind of like a placeholder for what you want to handle in this result error variant, right? So yeah, this is how to do this. And this is where the assertion will test to make sure that it works as intended. So we want to capture this. I think I want to capture all of the, so I want to do this. We want to see SnForge test. So yeah, I want to capture these tests. So before we do that, I think I want to clear my terminal, then run this. Let's see. So matching is kind of like a robust way to handle errors, right? So you want to kind of like know the kind of like you can actually, it gives you kind of like a more customized way to handle negative instances, like, right? So we have a validation here. We want to check that this line 75 is asserting that once we get our counter state variable, once it's 0, every attempt to decrease it below 0 should throw an error. So right, so we should not decrease below 0. That's basically what we want to test here. So we're using this keyword, our safe dispatcher, to kind of like validate that this decrease counter function is valid. We can actually see another method to kind of like replicate this, I think, before we consider the other reset counter. I think because of time, I don't know if we have time to cover other things. So let me see, let's say this. So yeah, so I want to test panic decrease. So instead of save, we'll just remove the save, because there are two ways, right? We can do this, and there's a method called what? Should panic. So yeah, should panic is we have unexpected, and we should kind of like can do this. Any of them works, kind of like any way you want, but this gives you more control when you use the safe dispatcher to target negative scenarios. So yeah, so we want to kind of like what we did here, just copy this, bring this in here, and the next thing is to kind of like decrease count. So we will notice something here. So in our test, right, all of the state changing function, increase count and decrease count, anybody can call it, right? But in our reset counter, when we test it, we'll see that nobody can just call this reset counter function. So whether or not we perform this mock by calling this stat, where is that? Yeah, this stat cheat caller address, this test will always pass, because there's no restriction to who can call the decrease counter function. So basically what we're going to do here is to say counter dot what? Decrease. So basically an attempt to decrease it below 0 is 0 at this point. So we're not using this method. We're going to simply ignore it. So yeah, and this should work. So the name of this should be, I think I should, yeah, so this is our test. So SnForge test, so basically this. So we should expect that this should panic. So David, are there questions?
Question from Alexander. Is there some logic as in Foundry and Solidity to do a setup that will run before every single test?
Oh yeah, so basically that is what is happening here in our deploy util function. So yeah, so before you remember, this is a different file. We have our counter here, and then we have our test here. So we want to kind of like, within this SM Foundry folder, we have our contracts, and we have our contracts in the source file, and we have our tests. So they are different folders, right? So we want to kind of like configure our environment, our test environment, to know that this, to know about this counter contract. That is what we did in our util deploy function. So we're using this util deploy function to kind of like initialize our declared and deployed contract. And this is what we call in each of our test cases. In our own test counter deployment, we are calling this deploy. So that is what we're doing each of the time we want to test a given scenario, right? So you can't just test, you must kind of like deploy first. So this deploy returns certain values we will want to use in our test. So that is what we're doing. So that is why we always have this deploy util function. Always have it in your test so that you can call it anything you want to call it. You can call it setup, anything you want to call it. But in my case, I'm just trying to use this as an easy way for me to kind of like showcase how we can deploy, right? So yeah, so let me check and see. So you can see our test passed. So yeah, so running this, so whether we do using the save dispatcher or we call should panic attribute, they kind of like are used interchangeably to kind of like handle validations within our function, our functions, right? So in this case, in line 75, we have an assertion that count should be greater than 0. So we use our save dispatcher using the match keyword, and we can actually use this to also capture that assertion logic. So yeah, so move on to the last. Okay, I think I want to test that this decrease counter is decreasing, right? So I think these are the negative scenarios. How about a successful test case where my decrease was successful? So what I'm going to do, so basically test successful decrease counter. So what I did here earlier, so I'm going to copy this guy, paste him. So instead of this 0 count, I will say, okay, let's still use 0 count. So let's say we want to kind of like assert that it is 0, right? And the next thing we want to kind of like counter dot increase counter. So we want to increase, and we want to have an assert here that our counter dot get counter equals 1, invalid increase, right? So after we increase it, I think we want to call this, okay, let's have okay, let's, instead of this count 0, let's remove this guy, and let's say we pass in like 5. I think this is fine. So we should have an assertion logic to make sure that this equals to 5, So yeah, invalid count. So so then call execute decrease counter transaction. So yeah, so this is it. Okay, yeah, so no need, okay, for this, comment. So yeah, so no need for this, so we should have this. So we should do counter dot decrease counter. So we should have let final count equals to counter dot get counter, and we should have an assertion here to make sure that final count equals to okay, I think I should save this as let count 1 equals to, let me copy this. I think count 1 equals to 5, yeah, so equals to final count should be count 1 minus 1, then invalid decrease count. So yeah, so let's check and of this test. SnForge test. So I didn't copy it well, so let me copy this well. SnForge. Yeah, so this should work. So it kind of like takes some time. So
Yeah, Dave, just gonna take this short time to remind you that we are close to 8 p.m.
right.
But let's finish
Okay,
the
so
code, but just a reminder that maybe we need to wrap it up.
Sure. I'm almost done. So yeah. So while we wait for that, let me quickly test our reset counter. So this is what we're going to be using our IO enable. So I think instead of writing the code, I think we just kind of like replicate it. It's easier for us. Waiting for it to compile, then give us the transition. Final count. Yeah, so this passed. So yeah, so I should have this. So let's test for decrease successful. Reset counter. So what we're going to do, so let's call it 5, and assert that count equals to 5. So so before we do this, we're going to say start call latched address. So we're going to call counter dot contract address. So we're going to simulate as owner. Yeah, identifier not found. Why? I think that call address. I think this should work. So yeah. So yeah. Then call counter dot reset counter. So basically, what we want to happen is that we want to reset count, and then after that we should stop ranking counter dot contract address. So basically, our session should change. We want to assert that let's see our counter dot reset counter equals to 0. So yeah. So yeah, success invalid reset counter. Okay, counter dot get counter. Sorry, think get counter possible invalid, not set. So yeah, I think this should suffice. So I think we'll wrap it up by validating that any attempt by non-owner to call this should fail. I think that's all. Yeah, I don't know if there are questions while we wait for the test to compile.
No questions for now. Just question about homework to do.
All right.
Yeah, I can answer live. There's a question from Constantino asking how is the homework going to be submitted? So at the end of the fourth session, around April 24, after the fourth session, we will send out a Google form, and then we'll ask for the GitHub repo link. And then you submit the GitHub repo link, and we'll check the codes there. And then once that is done, then you can get the 20 points of the homework.
So yeah, our test passed. So we can see that our test successful set counter passed. So that's the last test. Then let's use this so that we can actually cover all of this so fast. I'm sorry for time. So let me just use this so that we don't waste too much time. So yeah. So we want to cover the scenario where any attempt to call safe panic reset count by non-owner, safe panic reset counter by non-owner. So yeah, so this is it. So asserting that this. So what we're going to do here is to mimic. We're going to mimic a non-owner here. So when we come here. So yeah. So no need to stop the prank. So we're going to call by user one. So yeah, user one trying to call reset counter. This should fail. Reset counter cannot reset. Not reset. So what is the error? The error in this case is so when we go to, so this takes us to the Open Zeppelin's contract, right? So we want to check that caller is not owner. So this is the error message, right? We want to make sure that we grab this error message, any attempt to call non-owner. So yeah, so in Ownable, we're checking for every time that it is the owner, right? So not owner, assert only owner is kind of like to make sure that every function that is meant for the owner must be called by the owner. So yeah, so we want to do this in our tests. So instead of, let's just put this here. So basically that, we call this SnForge test. So yeah. We're using our field dispatcher in this case to measure, to validate that every attempt by non-owner to call this reset counter function fails with this error. Caller is not the owner. So basically that. So I think this should be the last before we go over to the quiz. So yeah, so this is passing. So with this, we've covered all of this, making sure that all of our tests are passing. So I think I want to run, instead of, let me remove all of the ignore, remove that and just run SnForge test to make sure that all of our tests, they are all passing. So yeah, I think after this, I think I'll hand over to you to go over the quiz. So yeah, so I want to make sure that all of our tests are passing. So SnForge test will run through all of the test cases that we have covered in this session. So basically, the testing creams counter, we're going to test that the emitted event is emitted. So the successful decrease, we're going to test that. We're going to also test that issue panic when a non-owner account tries to reset the counter, and then also issue successful reset the counter by the owner. So yeah, so basically all of the test cases should run and they should pass. So yeah, so all of the tests passing. So when you have this, it's good news. You should be happy, right? So all of your tests, they're all passing. And then with this, I think I hope we can actually start writing our tests. And yeah,